This session we will be learning about process management. What is a process, program under execution? Program is available in secondary storage device. Process is available with the resources with your program. So, for example, you take about C language code. You take about C language code. I have written main and I say that printf I and close this. So this is your program, right? You save it. I'm saving as hi.c. Now you will compile the program. After compile the program, if there are no errors, you will get a transformation object file obj. Then to this you need to add linkers and loaders. Once you add linkers and loaders, then this is a transformed to .exe. That means you add to this, you will get a what? .exe. What is the full form of that file name? hi.exe. This is after compilation. This is initial source program. This is source. It is converted like this after compilation. Then after adding linkers and loaders, it becomes a what? exe. Now you can run. So when you are running, you are at right now CPU plus memory also. Both the process is occupied. Program do not occupy anything of CPU resources and memory. Program is available in secondary storage devices as you are bringing from secondary storage device and placing onto random access memory. When you are placing it, then you are able to see on the screen. This is the overall idea. And what happened? So whenever you are converted into .exe file, this one I want to quote it as a what? Process. This I want to quote it as a what? Process. This I want to quote it as a what? Program. Program under execution is a concept of process. Program without resources. Process is what? With resources. Program is a what? Passive. Process is a what? Active, because it's a RAM. Program cannot be suspended because it is not running, but process can be what? Suspend because it is running. They are the synonyms between program and process. Then what happened? Whenever you create a process, there is a concept called process table. Process table is created for you. Operating system creates a global table which is known as process table. It gives a number that if there is one process, it will write that process 1 number will be given. If there are 2 processes, it will give process 2. If there are 3 processes, you will get process 3. For example, I am listening songs and I am compiling the program. So 2 processes are running. For every process, what is created? Process control block is created. For every process, what is created? Process control block is created. So process control block is a local to the process. But process table is a what? Global. All the processes are there in that. But process control block is individual. That is belongs to each process. It's not a global. Process control block is created. It will be destroyed at the time of completion of the process. So that is an idea. So what exactly the meaning of a process? What is an abstract entity? We will discuss in lecture. The process. Program is under execution, also called as unit of execution, dispatchable, and stands up a program assignable to processor. These are the names: program and process. So this is the abstract view of process. I already created which file? i.exe. This is what? i.exe. Now immediately it opens in your memory stack section, heap section, data section, and the text section. Stack consists of what? Recursive procedures. Heap is for dynamic allocation of memory. Data consists A is equal to 10, B is equal to 20, and there are any text instructions. So this is the abstract view of process. So program consists of data and code. Code is nothing but instruction only. Data may be static data, nothing but variables. Data structures, both sizes are known in Python. Dynamic means I do not know, so therefore you need to create at the time of runtime using dynamic memory allocation, MLlog, CLlog, and reallog functions. And runtime stack, activation records are maintained wherever function calls are generated. Every process maintains the stack for storing addresses which is having recursion nature. So this is the process table. For all the process table is created and it is linked to the process control block. Process control block is a local which belongs to particular process. So for example, this is one of the process control block given to one process, which consists process number, process state, program counter, number of files open, number of registers you open, program counter, everything. This is known as context. This is known as context. When you see at an instance of time of all the attributes of a process, which is there in PCB is a context. Sometime context may be changed. For example, initially, the state is ready queue. If at all it is executing, state is migrated to run. So it may be changed, context may be changed. That's why loading of the context, saving of the context, two particular words are there. Now what each attribute is talking, let us discuss. Process table is every process has its own process control block and it consists of process ID, PCB pointer, and process control block consists of process number like P1 and P2, and the state consists of initially new state, ready state, or run state, or waiting state, terminated state. They are. And priority, is it a high priority or low priority? And program counter, current instruction to be fetched, and any CPU registers you have used, any accounting information you have used, any files you have opened or not, that is the information is available. So process states. Whenever you create a process, the process may be having a states. New state, a ready state, run state, block and wait state, termination state, suspended ready and suspended block. Whenever you create a process, you are in new state. Processes are created. Once the process is created, who is responsible to create the process? Long-term scheduler, LTS. Long-term scheduler. Long-term scheduler is responsible for degree of multiprogramming. It creates the combination of burst time and IO time. It shouldn't be IO bound jobs or CPU bound jobs. If it is CPU bound jobs, if more time the process with CPU, IO will be idle. And there may be a chance of starvation to others. If you are too much time in IO, then it is get to be what? Waiting state. So your waiting time is increased. There should not be pure CPU bound. There should not be any IO bound. It should be combination of CPU bound and IO bound. That is taken care by long-term scheduler. So the degree of multiprogramming is decided by LTS only. How many jobs I need to create. Then all the jobs are entered into ready queue. It is a data structure queue only. It may consist a limited memory or huge memory. That depends. Then, if at all no space in this ready queue, immediately the process is suspended. They are suspended. Or space is available. No space is available in ready queue. Already filled. If it is available, it will come back. Resume. Okay. Then CPU scheduler picks one process. Here short-term scheduler also known as CPU scheduler, and that process will be given to CPU. Right now the CPU run the process. If the process is completed, then immediately takes you to which state? Terminated state. It is terminated. Whatever the resources you are allocated, they will be deallocated. Okay. If at all I am at the run state, right now CPU is busy in running my process, I require some input and output. So therefore, keyboard functions and monetary functions are there. IO block. In this case, the process are there for input and output operation. It is also queue only, which is limited. If no space in this, already some processes are there. If you see, there goes to run state is completed. Then if you need any IO, it comes to gate block. Once IO is complete, it goes back to ready. If ready queue do not have a room, it's suspended. Suspension taking care. If wait block do not have any space, it again suspended. And you see the cycle between ready state and a run state. In the case of, there is a cycle between ready queue and run state. In the case of round robin, in the case of preemptions. This is how it happened. The degree of multi-programming is decided by the LTS only, because it keep on creating jobs. It keep on creating jobs. That's why degree of multi-programming depends upon LTS. LTS taking care of good combination of CPU time and IO time. So what is the context? Context is the current PCB is nothing but context. Whether a process is in a run state or ready state or IO state or terminated state. So that is the meaning of a context. Context switching. So sometime the process is in ready queue. Imagine P1 is in ready queue. Sometime the process is in a run state. Sometime the process is in IO. See how it is switching. It is going from here to here. It is going from here to there. So P1 is moving there and here. It is nothing but context switching. So whenever you're trying to change the process at different places, and sometime a ready queue swaps with the old process in the case of preemption, and P1 has to come back. So this time P2 is occupied in the case of high priority and low priority. So that is the concept of what? Context switching. Context switching is nothing but a load, because you are pausing a previous process. I'm watching, for example, a movie. Right now I'm in run state only. You're accessing memory and you're accessing movie also. That means monitor and CPU. Now suddenly a call come to me. Then this movie is paused. That means this movie is going to which state now? Pause state. Suspend state. So you are loading, because I have watched up to one certain instance, 1 minute or 2 minutes or 1 hour. It has to carry forward from that particular time. It shouldn't go to the start. So that instruction it will write in the context where I am. That is written in a program counter. So it immediately save the current context where I have stopped. Then load the upcoming process. So upcoming process is executed. Once it is executed, because it is higher priority, then it continue from where you stop. That is the meaning of what? Context switching. Context switching is save the context of current process, load the context of new process. So this is what it looks like, context switching. So there are two processes, process 1 and process 2. Right now process 1 is executing by CPU, and there is a request come from process 2 that I want to use CPU because I am having higher priority, I am suspending you. Okay, in such case you can't kill the previous process, need to pause it. The pause is nothing but save the current context into PCB1, because process 1 is context is available in process control block 1. Then load the context of process 2. So process 2 right now with CPU. After P2 is completed, again you need to load the context of P1. You need to load the context of P1. If it is complete P2, you remove it. If it is not completed, you save it. So likewise, saving and loading, like round robin. Sometime P1 is with CPU, sometime P2 with CPU, sometime P1 is CPU, sometime P2 with CPU. So load the context, save the context. So types of processors, CPU bound and IO bound. CPU bound, it requires more CPU time. It is taking more CPU time, that is CPU bound. What is IO bound? It requires more IO time. If it is taking much CPU time, I am busy with CPU for n number of units. For example, P1 is right now with CPU taking 200 units. So rest of the process who are coming like P2 and P3 and P4, they are in where? Queue. They are in queue because P1 right now with CPU. So you can't have much more CPU time. So it should be less CPU bound process, it should be less IO bound process. If you choose IO bound process, then it stick on the process will be with IO for a huge number of units. That's why the selection of the job is supposed to be the good combination of CPU bound and IO bound. Therefore, two particular resources are get utilized. CPU is utilizing, IO also utilizing, like input and output. So schedulers. So long-term scheduler is nothing but creator. Creation of the job is performing by long-term scheduler only. He is known as a creator. Short-term scheduler, who sends the job from ready queue to run state? Who sends the job from ready queue to run state? Its lifespan is less. Mid-term scheduler, swapper, suspends the jobs. Suspends the jobs. Dispatcher is the component who dispatches the jobs from ready queue to run state. So LTS, STS, MTS. LTS is responsible for creating and bringing the new process into a system. It is also known as a job creator or job scheduler. The degree of multi-programming depends upon long-term scheduler only. It takes the good combination of CPU time and IO bound time. The short-term scheduler, it is responsible of selecting one of the process from the ready and scheduling on to run state. Mid-term scheduler, it is responsible of suspending and resuming processes. The job is done by a mid-term scheduler is known as swapping. What is a swapping? If there are some resources available, I can place it in a RAM. If no resources is available, again it get back to hard disk only. This is your hard disk where the processes are created. If there is enough space, then I can keep it. Those processes in the RAM. This is what is the meaning of roll in, swap in. Roll in or swap in. If there is no room, for example, P3 is come, I have a room, so I am in it. And one more process has come, there is no room. So P1 I am taking out and P4 I am adding here. So when you are bringing the process from there to here, it is known as a roll out, also known as swap out. This is done by swapper. This is done by swapper. So dispatcher, it is a software program that allocates the CPU to certain processes which is to be executed currently. The dispatcher is responsible for saving and loading the context, pausing and playing. So the context switching is done by dispatcher. So swapper, I already shown you swapper is bringing the process from memory to secondary storage devices. This is what is the meaning of swap out and swap in. So if you look at this figure, swap out, memory to disk, swap in, disk to memory. Memory here is nothing but random access memory only.